Okay, so we have our arctan function that relates this. So if I click my mouse at a particular point, A, B, I can pass in, math.atan2 b comma a. Just kind of, I have to reverse these, notice. The y is given first and then the x. And then it'll give me this, this arc length. If the radius is 1, it gives that arc length. So let's see. So now let's kind of, we want to kind of relate the arc lengths and degrees, right? That's one thing we'd like to do. So this is a unit circle. So the function that defines the circle is x squared plus y squared equals 1. You've probably seen this in school before. So and the idea is it's the Pythagorean theorem, right? So if there's we can think of a triangle here, a right triangle. The height of this triangle squared plus this. So for this one, as this says, the square root of 3 over 2 comma 1/2, right? The square root of 3 over 2, the quantity squared, plus 1/2 the quantity squared has to add up to 1. And that's true all the way around the circle, right, for all those points. But what we've got, and something that's a little different here. So when we were looking at this, we had negative arc lengths, right? After we got to 180, it flipped around to negative. You also see unit circles very, very commonly going from 0 to 360, or 0 to 2 pi. All right. But we can see using a circle like this, we can pretty easily relate. We see that if we go from 0 to pi, that's 180 degrees. We can actually use this arc length. If we're restricting ourselves to a radius of 1, we can use this arc length as a measure of degrees, or as an angle measurement, not as a measure of degrees, right? Well, we can say, and it's done that way. It's actually done, and you might have seen this before too. That we call it radians. This arc length we refer to as, when the radius is 1, we refer to it as radians. Okay, so pi radians is 180 degrees. So if pi radians is 180 degrees, we divide both sides by pi, we get 1 radian is 180 degrees. Or dividing both sides by 180, we get 1 degree equals pi over 180 radians. So we have a nice correspondence between that arc length and our angle, right? So we have our arc length, and we kind of saw that before too. When the arc length is pi, then the angle is 180, and so on. And let's see, what else did I want to look at? Oh, yeah, with these numbers. So there's why did we have stops at these numbers for this picture? And you'll see pictures like this a lot of times. Again, this is something you may or may not have seen in school. I'm sure you've seen the Pythagorean theorem. If we have a triangle whose hypotenuse is 1, and it's a 45-45, right? If it's 45 degrees here, and this is a right triangle, then it has to be 45 degrees here because it has to add up to 180, right? So you have an isosceles triangle here, and if the hypotenuse is 1, then the side lengths have to be square root of 2 over 2 because of Pythagorean theorem, right? So here's how you calculate it out. You square both these values, and you get square root of 2 squared over 2 squared plus square root of 2 squared over 2 squared, which gives you 2 over 4 plus 2 over 4. That's 1/2 plus 1/2. That's 1, and the square root of 1 is 1. Okay, and there's a similar proof for 30, 60, 90s, right? So if you have if this is 60 degrees and that's 30 degrees, this length will be 1/2 and this will be 3/2. So if you look at our unit circle where we have 60 degrees, we have our xy is 1/2 square root of 3 over 2. And this turns out to be pi over 3, right? Because 1/8 pi is the same as 180. Pi over 3 is 60. So that's 60 degrees, right? And then here's our 45, 45, 90. If we're going to have 45, then again, pi is 180. 180 divided by is 180 degrees. 180 divided by 4 is 45. And then here's our x and y are going to be square root of 2 over 2, square root of 2 over 2. And you can kind of use that, the 30, 60, 90 triangles and the 45, 45, 90 to kind of figure out all of these points around here. So that's pretty cool. So that's a nice correspondence, just using what we know already about certain triangles. So what do we have left to do? I think the one thing we have left to do is, if you already know this angle here, either measured in degrees or in radians, how do you get the point? And that is done with sine and cosine that we'll talk about next time.